Trinomials that have the form ax squared plus bx plus c can be factored using what's called the AC method. And these trinomials, the a, the b, and the c, are all numbers that we're going to use to help us figure out how we can factor that particular trinomial. Notice in the way that this is written that a is the number multiplied by x squared, b is the number multiplied by x, and c is the constant by itself. Sometimes problems may come where the trinomial is not written in this order. It may be written like this: 6x plus x squared plus 8. But just because we rearrange the order of the terms does not change which number is A, which number is B, and which number is C. C is always the one that stands by itself. B is always the one multiplied by the single x, and A is always the number in front of x squared. When we identify A, B, and C, we can use those numbers, just like we did in the number puzzle, to find factors of the product of A and C that add to be B. And once we find those factors of A times C that add to be B, we rewrite the middle term. We split the middle term into the special factors that we just found, and then factor by grouping. Let's see this in action. Starting with the first example, x squared plus 6x plus 8. 8 is our constant. 6x is being multiplied by x, so that is our b. What number here is in front of x squared? This is not meant to be a trick question, but it could be seen as that. We don't have a number in front of x squared, but we don't want to write 0, because 0 times x squared means we have no x squareds. We have 1x squared. I usually call that the invisible one. Once we find A, B, and C, now we can set up our number puzzle. A times C, 1 times 8 is 8, and B is 6. Then I look for two factors that multiply to be 8 and add to be 6. You may see some of these right away, and it may take a few tries before you find the number pair that works. Suppose we don't see the number pairs right away. Let's start with 1. 1 times 8 is 8. 1 plus 8 gives us 9. Well, 9 doesn't work. We're going to have to cross that one out. So then we try another number pair. Let's go to 2. 2 times 4 is 8. And sure enough, 2 plus 4 gives us the 6 that we need. So we're going to keep that number. Since 2 plus 4 is 6, the factor pair we need is 2 and 4. Now that is exactly what we did in the last class with the number puzzles. Now we're going to push a little bit further. How do we use the solution to the number puzzle to help us factor the trinomial? Let's start out by writing the trinomial again. And this time, with our trinomial, we're going to take the 6x and rewrite it in terms of our factor pairs. So since we have 6x, 2 times 4 multiplied to be 8 and added to be 6, so we're taking from that number pair. But we want to make sure that the numbers here, but we want to make sure that these terms match the term above. So we're splitting this 6x. We want to split it into 2x plus 4x. The terms that we create have to match that middle term. They have to be like terms. And then we can just copy the first term and the last term down, x squared and the 8. Now we factor by grouping. Just like we were doing with 4 terms, group the first 2 and group the last 2. Find out what is in common in the first pair. Well, x squared plus 2x, they have an x in common. And then x times x gives me x squared. X times 2 gives me 2x. Bring the plus sign down. So this plus sign. 4x plus 8, what is their greatest common factor? 4 and 8 have a 4 in common. 4 times x is 4x. 4 times 2 is 8. We are not done because the big operation going on in this expression is addition here in the middle. If we are factoring, we need factors to occur, which means we need multiplication to be the big operation in the middle. So there's one more step. Looking at the problem, do these 2 terms now have something in common? Indeed they do. They have x plus 2 in common. So we're going to pull that out as a greatest common factor and then write down what's left behind. X plus 4. Writing down what's left behind is actually the undoing of the distributive property that we were talking about when we were doing factoring by grouping and other greatest common factor factoring. Now we have multiplication between the 2 parentheses. That is our final answer. X plus 2 times x plus 4. We can do a quick check with our work. X plus 2 times x plus 4. When I'm multiplying polynomials, I like to use the box method to do the multiplication. So x plus 2, x plus 4. We write each one of these polynomials on the sides of the rectangle, and then we multiply. X times x in here, where the row and the column intersect. X times x is x squared. X times 2 is 2x. X times 4 is 4x. And 4 times 2 is 8. And notice if we write this down, x squared plus 2x plus 4x plus 8. And then we can combine like terms, x squared plus 6x plus 8. We end up with the exact same problem we started. And so we know that our factors of x plus 2 times x plus 4 is the correct factorization for our trinomial x squared plus 6x plus 8. You can also try foiling this. Foil, first, outer, inner, last, only works on multiplying binomials. So just be careful when you're multiplying factors back out. You can only use FOIL on 2 binomials multiplied together. I will leave number 5 for you to try on your own, and also with number 6. A little bit bigger numbers there, and number 7. Let's take a look at number 8. Number 8, 2x squared minus 21x plus 40. Now a is not 1. First, check for a greatest common factor. 2 and 40 have a common factor of 2, but 21 is not even, so we cannot pull anything out. Let's write down these numbers. A is 2 in front of the x squared. B, we're going to grab that negative with the b, negative 21. And then C, positive 40 as the constant. And then we multiply numbers together. A times C, 40 times 2 is 80. And B is negative 21. Here we have a different situation. Now we've got a negative number thrown in for B. We need to still find 2 numbers that multiply to be positive 80 and add to be negative 21. The only way we can find numbers that multiply to be a positive number and add to be a negative number are if the numbers that we start with are negative. So we need two negative numbers that multiply to be 80. 80 is positive. The only way we can multiply to get a positive number with negative numbers is if we have an even number of negatives. And then we need to find those number pairs sums to see if those sums add up to negative 21. Let's start at the beginning. negative 1 times negative 80, negative 81 when we add them. So remember, we're adding. So negative 1 times negative 80 is positive 80. Negative 1 plus negative 80 is negative 81. Remember, over here, we're writing the sums on the right. Negative 2 and negative 40. 2 times 40 is 80. So negative 2 times negative 40 is 80. And our sum is negative 42. 3 does not divide 80, so we're going to erase 3. It doesn't work. Skip down to negative 4. Negative 4 times negative 20. Negative 4 times negative 20 will give us positive 80. And when we add them together, we get negative 24. Negative 5. If we need to use our calculator, we absolutely can. It's perfectly fine to use our calculator. 80 divided by negative 5. Is it a whole number? Yes, it is. Negative 16. Negative 16 plus negative 5 is the negative 21 that we need. So we are going to grab those two. We're going to grab those factor pairs. That factor pair. Negative 5 times negative 16 is positive 80. And if we add them, negative 5 plus negative 16 gives us 21. That's the B that we're looking for. So we're going to grab that factor pair. We can stop once we find the factor pair that works. The next thing I want to show you before we move on to the factoring of the trinomials, if we write our factor pairs in a pattern, notice I start with a small negative and I get bigger. Notice what happens to our sums. We have a big negative number, negative 81, negative 42, negative 24. It's getting closer and closer to the number that we're looking for, negative 21. It's a good way to tell if we're ever going to make it, because if we were to try the next number, which wouldn't be 6 or 7, it would be 8. We could try 8. And again, you don't need to do this. We already found the factor pair, but let's just see what would happen. Negative 8 and negative 10 would give us negative 18. We know here we've gone too far. If we write in this pattern, we can capture this pattern of getting closer and closer to B. And notice with negative 8 and negative 10 being negative 18, we've gone past it. Rewrite your polynomial. 2x squared minus 21x plus 40. We're going to take the middle term, negative 21x, and rewrite it using negative 5 and negative 16. And because I need my terms to be like terms, I'm going to attach the x's to the negative 5 and the negative 16. So negative 21x is negative 5x plus negative 16x. We're just breaking the negative 21x into two pieces that are equivalent when we add them back together. And we copy down the first term and the second term. Factor by grouping. Group the first two, group the last two. 2x squared and 5x, they have an x in common, so we can pull that x out. X times 2x is 2x squared. Notice when I'm doing this factoring, I'm pulling the x out, so what's left over? Well, if I pull one of the x's out, the 2 and another x remain. So I'm going to put those in the parentheses. And then over here with the pulling the x out here, what's left over? Negative 5. take that minus sign and bring it straight on down, minus. Then we have 16x plus 40. I need to find the greatest common factor for negative 16x and positive 40. 16 and 40 both have 8 in common. So I'm pulling out an 8 from the negative 16x. I'm definitely going to have an x. But in order to get 16, I need to multiply 8 by 2. And then for the 40, 8 times 5 is 40. Out here's a negative. I've got a negative 8. And I've got to say negative 8 times 5 is positive 40? No. Negative 8 times negative 5 is positive 40. So I just need to double check my signs. Negative 8 times negative 5, positive 40. That's going to work out for me. And then the last step, check these last two terms that you just created. Do I have like terms inside the parentheses? Those two parentheses must be identical in all their signs and numbers and variables in order to pull this out as a factor. In this case, they are. So we pull out 2x minus 5. And then the leftover x goes in the first part of the second parentheses, minus 8 in the second part. And here we have our solution for factoring 2x squared minus 21x plus 40. We can try that multiplication out again to check. I will leave that for you to try on your own. There are a couple more examples in here. 3x squared minus 19x plus 20. 10a squared minus 27a minus 28ax. No different. We're just using a different variable here for the unknown. And number 11, 6x squared plus 25x plus 14. Here's another example, a good one. Use your calculators. Don't be afraid to use those calculators. Use your calculators to try to figure out some of these big numbers. It is helpful. Keep practicing factoring trinomials. I will post another video for factoring trinomials if you'd rather use the box method. And so that concludes our examples for factoring trinomials. If you want to use a different method, it is acceptable. I'm not one to force you to change what you've learned already, but I do want to make sure that what you learned is correct and it's going to help you as you work to solve these problems, to factor these trinomials. So make sure in the end, when you multiply it back out, you end up with the problem you started, and that your problem is fully factored, meaning we only have multiplication as the main operation in our expression. Yeah, there's a subtraction there and a subtraction there, but those aren't the main operations. The multiplication in the middle is. So keep practicing, make mistakes, correct mistakes, keep working on it, and we'll take a look at factoring special products next.